All right, projectiles launch horizontally. So let's take a look at number one. A projectile with mass m is fired with an initial horizontal velocity vx from height h above level ground. Well, which change would have resulted in a greater time of flight for the projectile? Now, what you want to do here, remember, I showed you this in class. I showed you this in class. All right. If you drop a ball and you throw something horizontally at the same exact time, well, they both reach ground at the same exact time, right? And this goes with the idea of vector independence, and this is I covered this in a video. And while you throw something horizontally, you have a horizontal velocity in the x direction, but that has no relation to your y direction. Just because I throw something horizontally doesn't affect my velocity in my y direction at all. And this next give should show you what I mean, right? It doesn't matter if you throw something horizontally, which is indicated by the green dots. What's going to happen is that all your ball is going to do is going to make a parabolic arc down to the bottom. Because my vertical velocity in the y direction in both cases is 0. In both cases, my vertical velocity is 0, right? Starts at vertical velocity of 0, vertical velocity 0, even though my horizontal velocity is something else, all right? And so that goes with that idea. Let's go to A. Oh, we know that mass has nothing to do, right? Mass has nothing to do with how fast something falls. And I demonstrated this, remember, with a piece of paper on top of a textbook. This is very bad textbook, all right? That's I actually no idea what this is, but it's a got it's a paper on top of the textbook. And so remember, I did this in class. Put a piece of paper on top of the textbook, let it fall down. They both fell down at the same exact time, same exact rate. Number B, decreasing the height h equals divided by 2. That would decrease the time, not result in a greater amount of time. If I have the height, this is gonna fall faster. Decrease in time, not greater time. Increasing initial horizontal velocity to 2vx, that has nothing to do with it. Doesn't matter if you make this go this way much faster. It's my initial vertical velocity in the y direction is still 0. Doesn't matter if I shoot a bullet in the horizontal direction. It's gonna fall down to the ground at the same exact time. Number and D is the only correct choice. If you double the height, you're gonna increase the amount of time for the projectile to be in the air. All right, so the correct choice is D. 2, a ball is rolling horizontally at 3 meters per second. All right, so rolling horizontally. And you don't really need to show work for this, but I'm going to show work anyway. And you want to divide your knowns into x and y, 3 meters per second, as it leaves the edge of the tabletop 7.75 meters above the floor. So your displacement is negative 0.75 meters, right? And the ball lands on the floor 0.391 seconds later. T is equal to 0.391 seconds after leaving the tabletop. What is the magnitude of the ball's acceleration? 2.2 seconds after it leaves the tabletop. So the acceleration is what? All right, what is my acceleration? And time fits in both cases because time is a scalar, has no direction. My initial velocity in the y direction is 0. And so this is how you want to do it in the future. Well, what is the magnitude of the ball's acceleration? You guys should know this. My acceleration, if I'm on Earth, due to gravity, is always negative 9.8 meters per second squared in the y direction. All right, in the y direction. So the answer is C. Number 3. What is the horizontal component of the car's velocity at point A compared to velocity at point B? the horizontal component? Well, you know that in the x direction, well, in the y direction, you have an acceleration of negative 9.81 due to gravity, and gravity only acts downward. But your acceleration in the x direction, gravity doesn't act in the x direction. Gravity only acts in the y direction. And so your acceleration in the x direction when it's in air is 0. So if you don't have an acceleration in the x direction, remember acceleration is your change in velocity. Is your change in velocity over time. Right? Your change in velocity over time. If your acceleration is change in velocity over time and you have no acceleration in your x direction, well, does anything happen to your velocity in the x direction at all? Does your velocity in the x direction change? Velocity in the x direction never changes if you have an acceleration of 0. And so the velocity at point A and point B, they're going to be the same. Same. All right, 4. Plane flying horizontally. What is the magnitude of the horizontal component of the crate's velocity just before it strikes the ground? Well, remember, we have no acceleration in the x direction. So if my velocity in the x direction initially is 100 meters per second, well, what's the horizontal component of my velocity before it hits the ground? Well, it's still gonna be 100. Your acceleration is 0. You have no acceleration in the x direction. All right. So it's C. It's B. It's B. It's B. It's B. It is B. All right. 5. Approximately how far from the base of the cliff does the ball hit the ground? So at the base of the cliff, what that means is this right here, this bottom, that's what the base is. That's base. And so they want to know how far from the base, and let's say it lands here, this is landing. They want to know how far apart this is, all right? So they want to know what your displacement in the x direction is. So let's figure out what our knowns are. So our, well, we have a horizontal velocity of 25 meters per second. And our initial velocity in the y direction is 0. And the displacement in the y direction is negative 45, because again, if we assume that our starting location is 0, then this must be negative 45. And our acceleration in the y direction is 9.8 meters per second squared. And we don't have an acceleration here. All right, and we want to find out what this is. So we don't have 3 knowns here yet. We're trying to solve for x. We're trying to solve for the x component, displacement in the x direction, but we don't really have x, right? We need time here. We need a third unknown. We need a third known. So let's try and solve for time on this side first, because we have 3 knowns here. That means we can solve for time. So we can solve for time. D is equal to VIT plus 1/2 AT squared. So now we have negative 45 equals 0 plus 1/2 negative 9.8 t squared. So negative 4.5 negative 4.9 t squared negative 4.9 negative 4.9 t squared. And it gets somewhere around 9. Somewhere around there. I don't know. Somewhere around 9. And then when you take the square root of this, well, then you're going to get t is equal to 3 seconds. And so that's your time. So now what we can do is write t is equal to 3 seconds there. And now that we finally have our time here, we can solve for displacement in the horizontal direction. All right, let me erase this. Let me use the same exact formula because that's everything we have. D is equal to negative 45. Well, that's not actually my bad. We want to find out what dx is. So dx is equal to vi is 25, t is 3, and because acceleration is 0, everything on this side is 0 as well, 75 meters, and that is our answer. Our horizontal displacement is 75 meters. Hopefully that helped.